Hey guys, how are you all? This is the first introductory tutorial video on SAP 2000. So I'm currently using SAP 2000 version 18.2, and if you don't have this software, you don't have to worry. There is another tutorial video where you can get this software for free. Alright, so okay, so for this tutorial, I'll be showing you by drawing this beam, and I'll be showing you how you can get a shear force and bending moment diagram of this beam. Okay, so the span of this beam is 10 meters, and the 5 kilonewton load is acting at the center of the beam. Okay, so this is the x-axis as you can see here, and perpendicular to this is the y-axis that goes like this, as you can see in this diagram, and z-axis is the vertical axis. All right. Okay, so after having the clear example of this beam, let's go to SAP, and once you open this software, go to file and click on new model. Okay, so you can see initialize model from defaults with units kilonewton meter centigrade. Alright, so you can see three units right over here, and the first unit is the unit of force, second unit is the unit of distance, and third unit is the unit of temperature. So kilonewton is the unit of force, meter is the unit of distance, and centigrade is the unit of temperature. Alright, so there are lots of templates available here, so you can draw beam, 2D truss, 3D trusses, 2D frames, wall, and everything else, but the most flexible template is this one, grid only. So all the tutorials that I'll be teaching you in this series will consist of using this template only, and we won't be using any other template because they are not as much as flexible as this template is. Alright, so click on this only. After that, you're gonna see this dialog box. Don't worry what this is, you'll understand it later, and click on OK. Okay, so after that, you will be seeing two windows parallelly. So first window is in XY plane right over here, and second window is the 3D plane. Okay, so let me give an short description of what SAP window looks like. So here are file menu bar. This is the menu bar, and you can see file, edit, view, define, draw, and many other things. What they are, we're gonna see later. Alright, so there are other icons right over here, and you will get you'll understand these icons later in this tutorial. Alright, so okay, so after once you jump into this window, and I mean land into this window, what you do is that you double click on any grid point right over here or here or any other, just double click it. Okay, so you will see this dialog box. Okay, alright, so here it says X grid data, Y grid data, and Z grid data. Alright, so what X grid data is that for in SAP for drawing anything, all you have to do is that you have to make grid. For example, if you have to locate this joint, you have to make a grid for this joint, and if you have to locate this force, you have to make a grid for this force, and same goes for any other thing that you have to draw. Okay, so as I have already said that this is the x direction. So in x direction you have to locate this support and this force and this support. Therefore you need how many grids? One grid, two grid, three grid. Alright, so you need three grid in the x direction. So what is the spacing for those grids? So spacing from this grid to this grid is, so you got a grid right over here. Alright, okay, so I'm sorry. So you got a grid just like this, right? And next grid you got like this, right? And next grid you got like this. So so what is the spacing between these two grids? So spacing between first grid and second grid is 5 meter, and second grid and third grid is 5 meter, as this force is located at the center of this span. Okay, so if you consider this point as the origin, so coordinate of this point is 0. Alright, so in x grid data, don't look at y or z grid data, just look at the x grid data, right? So the spacing for this is 0. Ordinate for this point is 5 meters, and ordinate for this point is 10 meters. So we gonna tell the SAP that we are making three grid in x direction, and the ordinates are going as per the requirements, right? So okay, so grid A, so this is the grid A, so this is grid A, this is grid B, and this is grid C. Okay, so ordinate of grid A is 0, ordinate of grid B is 5. So here you don't see any unit, right? So there is meter, and another right over here you can see it's the unit of length is meter. Okay, so C grid is at 10 meters, so we don't need the D grid, and therefore we delete it, right? Okay, so in the Y direction, however, here, alright, so X grid data, I think you're clear about it. In the Y direction, there is no any grid required because the beam is in the X direction only. So in the Y direction, however, we require only one grid. This for locating this line. Okay, so therefore there is only one grid, and rest we can delete it. Same goes for Z direction, right? So we delete it. After that, we click on OK. Alright, so if you don't see any line over here, don't worry, just click on XG plane. So XG plane, so this means that we are looking like in this direction vertically, right? If vertically, we are looking at this beam. Okay, so after that, so once we make the grids, what we next do is that we draw the beam. Okay, so for drawing anything in SAP, you have to go to draw option, right? Draw menu bar, and you can see a lot of options over here. So there is draw frame cable tendon. So beam is a member of frame, right? So beam is a member of frame, so for drawing beam we're gonna click on this option, right? Okay, so as you can see this icon over here, and the same icon is right over here, right? So so if you have to draw frame cable tendon, means that if you have to draw a beam or if you have to draw a column, you don't have to go to draw and click here. You don't have to follow that long process. All you can do is that you can just click over here, and there you go. So now you can draw, your arrow changes to this differently, and now you can draw a beam. So click on the first point right over here and take it all the way to here and click here, right? So once you are done with it, you can click escape button, and you can see I have drawn a beam. Okay, so I have drawn a beam. So what I have to do next is, so I have to do is that I have to make these two joints, right? So make these two supports. Okay, so for this, select this joint, and oh, okay, so I have to give a sap something, right? So I have to give a sap that I'm going to use this joint. So remember that whatever you are giving sap is, you have to go to assign. So we go to assign and click on joint and click on restraints, and we need hinge right over here, and we click on hinge and click apply. Okay, we got our hinge over here, and after that we click on another joint and we click on roller over here and click on apply, and okay. Alright, so we have made a beam. So what is left now? So we the left is that we have to apply this 5 kilonewton load at the center of the beam. Alright, so select the beam now. Why we have to select it? Because we are going to apply the load on this beam. So select the beam and click on assign. Why assign? Because we are giving sap something, so we go to assign, and what we are assigning, we are assigning frame load. Why frame load? Because beam is a frame. Alright, so frame load, what kind of load we are giving? We are giving not distributed load, we are giving point load, right? So click on point, and load pattern, they don't worry what these are, we're gonna see later on other tutorials when I'll be teaching you how to draw, analyze a building. At that time we're gonna speak on in detail about these things. Okay, so point load, this is the location of the point load, and this is the value of the point load. You can see here it's a relative distance from end 1, and another is absolute distance from end 1. Okay, so this is the end 1, and relative distance from end 1 means that the SAP considers this entire span as 1 meter, and divides the beam as per the requirements. I hope we are getting this. And absolute distance from n1 means that SAP considers this entire span as 10 meters. Okay, so we're gonna select relative distance from n1. So at relative distance 0 means at this point we don't have any load, it's 0. At relative distance from 0.25 means midway right over here we don't have any load, so it's 0. At relative distance from 0.5, now at the center we have the load of 5 kilonewton, and at 1 we have got 0 load, and we click on apply. Alright, so as you can see we got 5 kilonewton load right over there, right? Okay, so 5 kilonewton load we got right over there. So we are on the XZ plane. However, if you are in the XY plane you won't be seeing this load, because in the XY plane it is not possible to see the load in the XY plane, right? So we have to go in the XZ plane for seeing the load, as you can see here. Okay, so after that we have made a beam where applied the load. What do we do next is that we run this model. Okay, so for running the model you have to go to analyze and click on run analysis. You can alternatively press F5 or click this icon over here. Okay, so click on run now. Oh sorry, you have to save this, so I'm gonna make a new folder and we give it sap files files. Okay, so I'm gonna name this beam. Oh, my caps lock is open, right? Okay, so it's now analyzing it. Alright, so this is how the beam looks after analysis. Due to the 5 kilonewton load the beam has bent, right? Okay, so click on start animation. Oh, now you can see the beam, how the behavior of the beam on the application of the 5 kilonewton load. So this is the exaggerated view, not the real view. The beam doesn't oscillate like this. Okay, so you don't have to get excited. Okay, so once you get this up to this point, what do you do next is that you have to see the shear force and bending moment diagram for this beam, right? So whatever you have to get the output from the SAP, you have to go to display. Alright, so shear force and bending moment diagram are the output of the SAP, so you have to go to display. So we go to display and click on forces and stresses. Alternatively you can click on this icon right over there. So after that we click on frame, cables and tendons. And okay, so case combo dead, don't worry what this is, I'm gonna teach you later. And so display type we are going to see the force, right? So component, so we don't want to see actual force, we want to see shear force and bending moment diagram. So shear, there are two kinds of shear here, shear 22 and shear 33. Shear 22 is the principal maximum shear force, and shear 33 is the principal minimum shear force. And here moment 22 is the principal minimum moment, and moment 33 is the principal maximum moment. So for getting the shear force diagram, you have to click on shear 22 and we see a fill diagram and click on apply. So this is the shear force diagram. So if you have to see the values, click on show values and click on apply. So you get the negative shear 4.14 kilonewton over here, and positive shear 4.14 right over here. So this is the sign convention what the SAF follows. Okay, so you have to see the moment diagram, click on moment 33 and click on apply. So this is the bending moment diagram. Alright, okay, so this is all for this video. I hope this video was helpful. If it was, hit like and subscribe for more awesome videos. And from now continually I'm going to give lecture videos on SAP 2000, and I'll be teaching you how you can analyze and design a building, a residential building. I'll be giving example and you can follow those tutorials to design any kind of building. So this is just an introductory tutorial. This is not how you design or make a beam. There are a lot of other things that you have to do before drawing a beam that we'll learn later. Okay, thank you for listening.